All right, so section 5.6, this is graphing rational functions. Now, the first two functions that I have up there are not rational functions. They're quadratics and absolute value functions. But I want to just write some information about them that you're going to find kind of like similar to what we're going to do today. So, we learned before that with quadratic functions, A told us if it opens up or down, meaning the graph either looked like this or it looked like this. Okay? So the A term, if it was positive or negative, would tell us if it opened up or down. Positive opened up, negative opened down. So I'll kind of put right here a little plus sign here, right here, and a minus sign, just so that we know that. Okay? So the A term tells us if it opens up or if it opens down. And then HK, you guys remember what HK was? Well, that was our vertex. Yeah, that was an important point, right? This was our vertex. Okay? So we can kind of say like the high or low point. Okay, meaning if it opened down, the vertex was up here, right? If it opened up, then the vertex was all the way towards the bottom. So it's either a high point or a low point, okay? And we got that by figuring out HK. Now, you do remember that H was always the opposite of what it appeared to be. So if it looked like X minus 2, then you would say, well, H is positive 2. If it looked like X plus 7, then it was a negative 7 instead, right? So H was always kind of like telling you a lie of what it appeared to be. K was always very honest, whatever it was. If it was positive, the number was positive. If it was negative, the number would be negative, right? So when we go over to the absolute value, okay, A still told us which way it opens, okay? It either opens up or down. So the graphs either look like this or like this. Okay, that's a positive A term and a negative A term. Okay, it either opened up or it opened down based on your A term. And then your HK was basically the same definition as quadratics. Okay, this was our vertex, right, for higher low points. So I don't know if you remember when we did this, but it should have been like if you understood when we did quadratics doing, or I think we did absolute values first, but if you understood absolute values, doing quadratics is about the same thing, right? Um, Now, the high and low points basically appeared like this, right? It's the low point of the absolute value or the high point, right? So that's where your vertex would be found. One thing I didn't mention was that A was considered our slope, kind of, right? Like for the absolute value, you could use it as a slope to figure out the next points. But for the quadratics, you really couldn't do it all the time, just the first time, right? But that's why I'm not listing. But all right, so we learned that before. We've gone over it. We learned it. We know the formula that it's supposed to look like. What does HK stand for? What A stand for? Well, now we're going to move on to rational functions. Okay. Notice I did highlight the A, the H, and the K. All right. Now the A still tells us its amplitude, like the way it opens, but there is no up or down in a sense. Okay. There's just a different way that it looks. So our A term, oops, sorry, let me change this to red here. So um, our A term right here, it tells us whether it's increasing or decreasing. So I'll kind of explain that. So it tells us if it's increasing or decreasing. Okay, now what do I mean by that? Well, the graphs look like this. And I'll put it on a coordinate plane later. But that's one graph right there. This is one actual graph. I should probably just do it now. So now if you trace the red line from left to right, Okay? So I'm going to use a highlighter just to kind of do this really quick. But if I trace it, notice right here, okay? So watch really quick. If I trace it, my pencil starts to move down. It's decreasing, right? It's decreasing. And then if I go back to the top part, it's still decreasing as I trace the line. You see how it's always my hand motion is always going downwards when I'm tracing, right? Except for when I have to pick up my pen and go somewhere else. But notice I'm decreasing and decreasing, right? So it's going down and like down and down, right? Every time. So I know that's kind of hard to see, but this graph, the left side goes down, and so does this one, right? It's going downwards. As you go from left to right, it's going downwards, right? And downwards on the other side. So this would be considered decreasing, okay? This happens if A is positive. So it's kind of weird. If A is positive, it's actually down, right? So if A is negative, then that means I should be increasing. Let me show you what that one looks like. So it's a little weird, but this graph will look like this. And this is if A is negative, okay? But if you trace, if you put your finger on the red line, right, going from left to right for the one that's, I put a minus on the bottom, you notice how the line starts to, it's like flat, then it increases up, and then you pick up your finger, put it at the bottom of it, and then you trace it some more. You're going upwards, right? You're trending up. You have an increase in the line. So that's kind of a little weird. Okay, so just remember if A is positive, it's doing the opposite, it's decreasing. If A is negative, then instead of decreasing, it's actually increasing. Okay, so and then the graph goes like that. Now I will tell you, it's probably better for you just to kind of memorize what it looks like when it's positive, memorize what it looks like when it's negative. That's what I do. Okay, and then HK. So for us, HK is not a vertex because notice there's no vertex in these graphs, right? There's no point where they touch each other and there's like a sharp edge or a low point, nothing like that. This is where the asymptotes intersect. The word asymptote, these are lines that are supposed to be invisible, okay? And right now I'm going to kind of draw it a little bit more to the right side so you guys can see it. But the word asymptote are invisible lines that cannot be crossed, okay? So I'm going to give us that definition right now. So an asymptote these are invisible. Now I put that in quotes because we're going to actually draw them, but dashed. Invisible lines that cannot be crossed. Now, just so you know, if you're starting to feel like, okay, this doesn't seem too easy, this is actually very easy. The way I go through and teach it for you guys is very simple. Okay, so don't freak out. I know there's a lot of definitions, but um, it is pretty simple to graph these things. Now, of course, they can give you more complicated looking graphs based on this, but we're not doing it. Okay, we can do that if you want to get the trig or calculus, so we can discuss different type of rational functions. Um, but for us, it's just like this. Okay. Now, what is it? What do I mean by asymptotes? Well, here you go. If I uh, draw just any one of these, I'm just going to draw a random one, okay? A little bit bigger here. All right, so your asymptote, and I'm going to kind of um, use a different color here, but here's an example of one of these, okay? It doesn't mean this is what they're all going to look like, but here's a vertical asymptote. Here's a horizontal asymptote. Okay? This little point right here that's supposed to be invisible, I kind of put a little marker on, right? You're not supposed to see it. That's HK. That's HK. So once you know your HK, put a little dot, like tiny, tiny, because you're not supposed to be able to see it. And then draw vertical dash lines from that point, straight up and down, and then from that same point, side to side. Okay? So you're going to do that immediately. Once you know where HK is, you'll start like this. Then you're going to look for your A term. Now, if A is negative, what am I supposed to do? What am I, is it supposed to be increasing or decreasing if A is negative? So A is negative, decrease, right? Um, so I'm sorry, increasing. I'm way off. It is increasing, right? Because these are going up, right? So all I'm going to do is I'm going to ignore the black coordinate plane. Ignore that. My new graph starts at my asymptotes. Ignore the black ones, okay? Because now my new center is HK. That's where it's centered. So I'm going to make it look like the negative graph right there. So this is what I'm going to do. I'm just going to draw it like this. And that's it. You don't have to calculate anything. You're just going to draw it. Now notice I'm not passing the green lines. I'm approaching them, but I'm not passing them. Okay? And this is all we have to do. Okay? You don't have to make a table of values. You don't have to do anything specific. The hardest part is going to be finding your HK and then remembering which way it should look like based on your H. Okay? But this is what your graphs are going to look like. So let me show you. We're going to do 4 examples. Um, but like I said, we don't have to do anything really. It's just observe and draw. Okay. So first thing I'm going to do just to get it out of the way, let me create a coordinate plane here. Okay. So 1, 2, 3, 4, 5. So I'll make it 5 by 5. Okay. Now you got to figure out 2 things. What is my A term? It's 2. So that means it's positive. So, okay, I'm going to kind of say, all right, positive. If it's positive, that means it's decreasing. Okay, remember it's opposite. All right, what's my HK? Close. -2, -3, right? HK is -2, -3. So I'm going to go to -2, -3 on my graph. -2, -3. And I'm going to put the smallest, tiniest little dot there. I don't know if you can see it, but it's right here. Okay? The tiniest little dot, because you're not supposed to see it. It's supposed to be invisible. From that tiny little dot, I'm going to draw a straight line up and down and left to right from that dot. But it's going to be dashed because these are supposed to be invisible lines. Okay? So notice I'm just doing this and then sideways from there too. So remember, my new center is these green invisible lines. I am now ignoring the black ones. I'm pretending they're not even there. Now, we said since A is positive, the graph should be decreasing. Okay? So that means that the graph to this problem looks like this. So since A is positive, the graph should be decreasing. And I'm done. I just did this problem. Notice, did I actually do any math calculations? No. I just need to find a couple pieces, A and HK. Then from there, I draw, and I'm good. Okay, these are very simple. They don't look like it. They look very intimidating, but they're very simple. Okay, so let's try another one. Any questions on this one before we move on? Like I said, we're going to do 3 more just for practice, and then I'll give you guys your homework. So um, let me again draw a um, coordinate plane here. think I did another 5 by 5. So 1, 2, 3, 4, 5. Yeah, 5 by 5 graph. All right. Now that I have that, I'm going to find the pieces that are important to me, okay? What is A? It's a negative one. You see the negative in the very front? It's a negative one, which means that it's, well, negative, right? If it's negative, the graph is increasing, right? It's doing the opposite. It's increasing. What's my HK? Negative 1 and 3. Okay, good. Negative 1 and 3. Okay. So I'm going to go to negative 1, positive 3. So negative 1, positive 3. I'm going to put a little tiny dot right there. I'm going to draw a vertical line from that tiny dot and a horizontal line on that tiny dot that's dashed. I'm just kind of drawing a dashed line here this way and this way. These are my asymptotes. I cannot pass them. And since A is negative, this graph should be increasing. It should be going upward. It should have an upward trend. Okay, so it's going to look like this. This is actually the hardest part of the whole thing, is remembering what the graph is supposed to look like. So there you go. I'm done with this problem. Okay. So again, no calculations really needed, a little bit of counting here and there, but nothing major. All right, let's do example 3. Again, some of these are your homework problems, so it's not a big deal, right? We're not wasting your time here. So we're going to sketch f of x equal to 3 over x plus 2. Again, I'm going to draw a coordinate plane really quick, so let me just do that. Right, so 1, 2, 3, 4, 5. All right. What's my a term? It's a 3, so that means it's positive, which means this graph is going to be decreasing. And what's my HK? Negative 2, not a 1, because I don't see a 1. 0, right? There's nothing there. So that means it's a 0. That's the reason why I did this one. Okay. You see something like that. It's missing that number at the end, right? So since it's missing it, that means it's a 0. Okay? So I'm going to go to negative 2, 0, and I'm going to draw, well, I'm going to put a little small dot, which is going to be kind of hard to see because negative 2, 0 would be right here, okay? So I'm going to have to put a little dot there, but you're not going to really see it. But I know that's where it's supposed to be. And if I zoom in, you can see it. Look, it's right there. Okay? It's very, very, very small. Okay? But it's hard to see it when I zoom out. So from that, I'm going to create vertical lines that I'm not supposed to cross, and also a horizontal line. Now the horizontal line is going to basically be the x-axis. Okay? So there you go. And then I'm going to draw my graph. Now my graph is supposed to be increasing, so since it's increasing, that means it looks like this. And then we're done. Oh yeah, decreasing. Thank you for that. I'll give you a point for that one. Yeah, it's opposite of the sign. So I put, it's a plus sign, so it should be going minus, decreasing. Thank you. So it should be going this way. Whoops, so then my hand slipped there. Slipped again. Screen's real slippery right there. I'll try to fix that one more time. Let's see. Remember, you're gonna be approaching that green line, but you're not gonna touch it. Okay? Get close to it though. All right. So last one, and then we're done. Um, this one right here. Like I said, it looks intimidating, the work, but it really isn't that difficult. Um, just try to remember, what happens when A is positive, when it's negative. So like right now, I just made a quick mistake and I said the wrong thing, right? And that's how easy it is to accidentally mark something or draw something incorrectly. So just be careful, check your notes, make sure you're doing the right thing. All right. My A term is a negative 1. Okay, so it's negative. That means this one is increasing. Okay, let's make sure I get that one right this time. So it's a minus, so it's increasing. It's rising up. Now my HK is negative 2, negative 1. So I'm going to go negative 2, negative 1. That's right here. Okay, draw a vertical and horizontal line that's supposed to be invisible. If you ever buy a graphing calculator, you'll notice they never draw these lines, okay? You're just supposed to know they're there, all right? So, um, and then from here, I'm going to do an increase, okay? So it's supposed to be increase, all right? So there you go. So just a real quick mention for this stuff. Remember, there's minimal math. It's just basically identify the pieces and you're good. Okay, you just draw it out.